Right, with trial and improvement, this is what you need, right? One of these calculators, Casio calculators, and you'll get to the answer. Now it says here, solution to this complex sort of looking equation here lies between 2 and 3, okay? So it says use the method of trial and improvement. So you try and then you improve, okay? So you try something and you don't quite get to what you want, you make it a bit better then, right? And that's how you get to the answer. Now it says it's between 2 and 3, so what we'll do, we'll try exactly what's in the middle of 2 and 3, right? 2.5. We always go for what's in the middle. So if you put 2.5 in here, okay, x cubed, right? Well, x now becomes 2.5, right? Okay, that's the value of x I'm going to substitute in here. So, you know, in terms of what I put in the calculator, I could do that, couldn't I? So replace x with 2.5, put in a bracket so it's clear. Okay, so I'll type that in the calculator. And I get that, press the SD button, minus 3.375. Now, I wanted it to equal 0, didn't I? But it was equal to a negative number, okay? So x equals 2.5 gives me a smaller value than I want. I want 0, but I end up being further down the number line. So this is going to be too small, right? X equals 2.5 is too small because it gives me an answer which I don't want. So what I'll do then is I'll try 2.6. Okay, I'll increase it. And you only increase by sort of one decimal place, so I'll go to 2.6 now, okay? So I'll put 2.6 in here. Now I don't need to write all this out again, right? I don't need to put 2.6, whatever. All I need to do is put the answer down in this particular type of question, okay? And this is every trial improvement question. The important thing is you write the answer. And you notice what I did then? Press the back button on here, okay? Because you can save typing it again, you can just replace the numbers, press the SD button then, and I get minus 2.024. Again, that's too small, isn't it? Because I want it to be 0 ultimately. So I'm going to try a bigger number, 2.7. Let's go back to that, press the back button, change this to 7. And I get minus 0.517. Again, too small. Okay, so I go back. I'm going to try 2.8. This time when I try 2.8, notice I get a positive number. Now, we've actually gone the other side of 0, haven't we? If you think of a number line. Okay, this was like to the left of 0, this is to the right of 0. This now is too big, isn't it? Okay, can't seem to get 0. But we're actually never going to get 0, okay? Because the answer is something that is a number, maybe the value of x will be going on forever. It'll be 2 point something going on forever, okay? But we know 2.7 is too small, 2.8 is too big. So what that means is the answer lies somewhere between 2.7 and 2.8. Hope that sort of makes sense. No, it does make more sense if I just draw a little number line, right? And this always helps because we want to get all of these marks. So far we've got 2 marks, okay? So 2.7 and 2.8. And 2.7 was too small, wasn't it? So I'll put TS there for too small, but 2.8 was too big, okay? So what we do then is we go in the middle, okay? We'll check in the middle to see where we should go, okay, from here, because 2.7 is too small an answer, 2.8 is too big an answer. So let's see if we can zoom in to see if there's an answer closer to 0. So we'll try in the middle. Always go in the middle of this, 2.75. So if you type that in, we get this. That's a positive number, isn't it? 0.296875. It's important you write it down, right? Because they're looking for that. You've now got your third mark. And of course that there is too big again, isn't it? Because we want 0. Now think about it. 2.75 is too big, which means then we can work out what side my answer is going to be on. Okay, 2.75 is too big, which means it needs to be this side of it, doesn't it? It needs to be less than 2.75. And if it's less than 2.75, it's actually then going to be here somewhere, and it's going to be closer to 2.7. So you've shown that actually the answer is 2.7 correct to 1 decimal place. Okay, you've shown what it is correct to 1 decimal place. In fact, you proved that it's closest to 2.7 and not 2.8.